So let's start this one. So parallel circuits, first better you just understand the the connectivity. It's not about the shape, it's about the how components are connected. Shape, like if you see this time, you can see that shape like rectangular shape, how they are connected, and it's look easy actually to understand. But shape could be anyone. So what is the logic here? What is the main point here which you need to keep in mind? That you can see resistance R1, R2 and R3 and R4, they are connected between 2 points. Yani one end of all the resistances you can see here connected to this line, red line, and another end of all the resistances are connected to this another red line. So they are connected accordingly this way. So let's just, if I say this upper one is A point, lower one is B point. So what I can say that all the components are connected between two points A and B. So this is a purely parallel circuit. It is a parallel circuit. All components, what are the components? Any R1, R2, R3, R4, they are connected between these two. Yani all resistances are connected in parallel. So as I said in the beginning, yani shape is not a matter here. Shape could be this way and shape could be another. So what is another? I'll just draw it. Just a minute. I'll draw so that you can see. Okay, so let's suppose this is point A and this is another point, okay, and this is how they are connected. Suppose this is one resistance connected here, this is another resistance connected here, another resistance connected here, or could be another one this way. All are connected basically. Let's suppose this is point A, this is point B. So what is the logic here? That they are connected between 2 points A and B. This is the point. So this picture is exactly same as this picture. Here what we did, we just extend the wire from here to here, wire extend. It's just a wire. It doesn't have any any resistance. So both things are same. Yeah, it is called node basically, where all are connected. So here we call this is node A. Okay, just give the name, for example, node A and node B. Junction is basically Mariam, the difference, very minor difference between junction and node. Junction is a point where two branches meets. But if more than two or two branches are meeting, it becomes node. Yani this is 2, for example. So this is a junction for sure, but it is not a node. In order to be a node, it will be having 2 and more. So it is called now node. Okay, if meeting 2, so we call junction. So this is junction and node, very common, what do you call, very similar words basically. But here we use node, yani 2 and more, in terms of what you call circuit terminology, we can say, we use it. Junction, yani whenever we say 2 points are connecting, yani this is there and another is there, for example. So this is called junction. But node have more extra thing, which is 2 and more. It is called node. All right, so this is parallel also by the fact that, girls, that if I connect a battery here, for example, all right, and because of this battery, what will happen? A current will flow. It will supply a current to this circuit. So this is, let's suppose, IT, total current. So now this is going to be split. Here, some current will go here, some will go here. Let's give the name accordingly. This is I think. So because of there is a multiple path, so some current will flow down, some will go here. Let's suppose it is here I2, it is here I3, it is here I3 and it is I4. Okay. So here And you know that from where I1, I2, I3, I4 is coming. It is very much clear. It is coming from the IT. So basically, this is the split up of the IT. So I can say IT is equal to I1 plus I2 plus I3 plus I4. Can I say this? Because IT is the total current, okay, which is splitting into different. So you know which law is this? This is a rule which we call Kirchhoff's current law, which says that, you know, the current meeting at any node or junction, as I said, you can use it at any point at any junction, you know, is basically the sum of incoming current is equal to the sum of outgoing currents. So basically, as I said, this is a single line. And also I draw another example for that with this picture, again drawing, yani this could also be considered this way. So this one and this one exactly same, okay, same. So here is IT total, and here we are considering I1, I3, I4, and this is I2. So if I apply here to this junction or node, okay, let's suppose it's same junction, and because they are the same words, junction, if I'm saying like that, so IT is gonna be split up. If you look here at this point, how many currents are coming towards the node or leaving the, you know, the node. So if you apply this one, so here is IT which is coming, if you any incoming. Otherwise, if you look for another ones, all these they are outgoing. So we can say simply, Kirchhoff current law is basically sum of incoming current is equal to the sum of outgoing current, because only one incoming current, all are outgoing. So this is something. Also, I can say algebraic sum of all the currents is equal to 0. Algebraic sum, by the way. So when we will taking algebraic sum, we will consider that incoming current is like, you know, positive and outgoing current is like negative. When we add them together, we will be getting 0. This is something. So this is called KCL and some basic understanding of the parallel circuit. Okay, we'll discuss more in detail after some time. So now a parallel circuit, yeah, V is a constant everywhere. Batul, you are right. V is basically is gonna be, let's see here, I'll clear this point also. So a parallel circuit is identified by the fact that it has more than one current path or branch connected to a common voltage source. So now you can see we have a common voltage source, girls, which is here, all right, which is here, and it is connected to all of them. It should be clear to you, because this is what this is here from to here. This is the same point. This is same point. Similarly, down it is same point. So a common source is connected across the resistances. So because of it, what will happen? The same voltage will appear across R1, across R2, R3, R4. Yani constant value or voltage across all the resistances. This is the point here. Okay, so what is the change here? The currents are different, but voltage is same. In contrast of the series circuit, current is same, but voltage were different there, what we discussed earlier, you know, in the last chapter. So if I got a chance to put a voltmeter across this, you know, any resistance, I want to check how much is the voltage across here. Let's suppose this is a 5-volt battery. So when I will put like that, see this one. So we have a 5-volt battery connected here, and we have some resistance values R1, R2, I3, and you can see all resistance are different. So, but the voltage across them is gonna be same. So when I put a voltmeter here, and by the way, you must know that how to connect voltmeter. Yani we should connect voltmeter parallel. Parallel yani one end must be connected to, you know, there, and another end is here. Red one is positive, okay, and black one is negative. So V is 5 volts, and this voltmeter is giving me reading, it is 5 volt. Okay, by the way, if you interchange these the probes, red and black, so it will become negative, because this is a positive terminal, must be connected to the positive terminal of the battery, and you know that the longer line is basically the positive, the short one is the negative. So it will like that. Now if I put this voltmeter across R1, see, same voltage, and same voltage. It means in parallel circuit, voltage is same, but current is different. All right. Okay. So, all right. Okay, let's just continue this one, and I will clear one more point here. So, girls, if I ask you, girls, calculate the current flowing through the resistors. Calculate the current flowing through the resistor. So, what will you do?
VR.
VR. Okay. So this is VR. Yani general formula you are saying. I want to know how much is the I1. I want to know how much is the I1.
5 over 618.
Okay, I should write first V1 over R1, correct? Formula is always good to write before, all right? Now V1 is what? We know that it is equal to Vs, yani it is 5, then over 680, all right? Now we can find it. How much it is? You can find it. Just calculate it. And I am getting I2 now. So for the I2, it is V2 over, sorry, R2, huh? V2 over R2. Yeah, so it is gonna be 5 over 1.5, or I can say, yeah, 1500. I can convert it into ohm, whatever. So, okay, so what are the values? Okay, you do one thing. While you are calculating the values, you must calculate the values up to 2 decimal, after 2 decimal place. Yani, if you are getting something 0.4357, you need to consider at least 2 digits. All right. You will drop this one. So you know the rule when we drop this one. So yeah, accordingly then you have to change it. Yeah, it will be 44. So bus whatever. So what is the I1 according to that rule? We need to apply the rule. Okay. So how much is I1?
7.35 milliampere.
7.35 milliampere. All right. What about I2?
0.44.
0.44 milliampere. It is also milliampere.
Yeah.
Okay. What about the I3?
The same, 5 over 2.2.
5 over 2.2, yeah.
2.27.
2.27. After applying the rounding rule, correct?
Yeah.
You apply proper rounding rule. All right. So these are the currents, it means is that these are the currents which is flowing here. This is I1. Is it clear, guys? I am writing very tiny, letters. Is it okay to everyone? Okay. Yes. All right. Because I am using today pen. So it is more clear. All right. Okay. So this is I3. All right. Now, and where is I total? I total, we know that it is somewhere here coming from this source. So this is IT. So if I ask you how much is the total current, so you can easily get the total current. Okay. So the formula, you know the total current formula. So you can say IT is the sum of all. So just get the sum. Yeah, I1 plus I2 plus I3, correct. So KCL, we will apply Kirchhoff current law. Add them 3.75, 7.35, 0.44, then 2. All right, we'll see 0.44 and 43. Is this correct? Yeah, that's why I'm asking. That's why I'm asking. It should not be. I'm just looking for that. It's not correct. Yeah, it should not be. I asked, you said yes. This is. If you divide 5 over 1500, it is gonna be different value. Yes, it should be something like that. So 3.33. Yes, milliamps. Correct. Now add them all and get the total current. Get the total current. 7.35, 3.33 plus 2.27.
It's 13.4.
13.4. 13.4. Yeah, it is correct. 12.95. And even maybe if you go exactly, it should be 12.98, I believe. I don't know, maybe when you truncate the values, you missed somewhere or what. Okay, it's not necessary to convert by Manar. It is okay if you want to keep it in ohms, or it's up to you. Here is you are saying in I3, so this is kilo, this is kilo, so I have to convert it. That will be 2200. Then you will get it, this one. This is just an example I give. So when you get it, this is gonna be almost 12.98 milliamps. Is it clear, Manar? Is it clear? Because you are asking to convert. Yeah, so convert, we already convert. This is in ohm. I already converted. This one is in ohm. We put it in the kilo. So yes, you can convert it or check it accordingly. So we get it I total. Okay, this is the one way to get the total. Okay, another way. This is one way which I teach you how to get that all currents and the total current. Another way. What is another way? Another way could be if we can find the total resistance. Okay, yeah, it is, yeah, Shahad, correct. No problem. Yeah, so 12.98, which is almost 13. All right, so this is one way. Hope it is clear to everyone. I will teach you the another way to get the total current. So for that we need to find the total resistance first. All right, so in order to find the total resistance, what is required? I am removing all these. If you need a screenshot, you can take. All right, so I'm removing it. And oh, by the way, yeah, this is wrong. This is IT. Okay, so remove it all. Can I remove? No. Why not? Okay. So if not removing, go to next. Okay, so girls, this is about the another way could be to find the total is to find the first total resistance. And I believe that you know this formula, which is about how to get the total resistance for a parallel circuit. This formula is called basically, you know, the reciprocals of the sum of reciprocals of the individual resistances. So you can see this formula, which is here RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. This is called reciprocal. Yani reciprocal means inverse. Reciprocals of the sum of reciprocals. This is the way. Or if you want to write in a different way, you can also say like RT is equal to, in the bracket, 1 over R1 plus 1 over R2 plus 1 over R3 and so on. how many resistance you have, you can just consider, okay, and the inverse. All right, yeah, to the power 1. This could also be written. So this is the way. So in the previous case, let's try to get the total resistance now. So previous case, I know that what were the the values, so I will just put it accordingly. So 1 over 680, I believe, ohm, yeah, 1 over 1500, which is on ohm. I am putting all in ohms. Another one, 1 over 2200 is. All right, now this is inverse. Okay, get it, the total values. 680, right? These values are correct or not? 680, 1.5, 2.2. All right, 386. Very good. 386 ohm. So now I got the total, resistance. After getting the total resistance, then others can also verify the value. I can also find the total.
Yes, 5 over 306.
Yes, so it is gonna be Vs, write the formula, over RT. And Vs, we know already, it is 5. So now I can say 5 over 386. Get this one, how much it is coming. Yeah, Mariam, you can also write, no problem. This is correct. But provided, this is, you are saying 1 over RT, 1 over RT. So once you calculate 1 over R1 plus 1 over R2 plus 1 over R3, you have to get the inverse in order to get the RT. What happens, students forget here to get the inverse, and they, because of that, yeah, need to flip. If you forget it, there are chances to, get the wrong results. It happens sometime. So it's up to you. It's not everything is same, but you have to calculate. All right. So how much is the value when you divide this one? 5 over 386. So you are getting 0.013 ampere. All right. Or yeah, another value is also, which is like that. So 0.0129, which is more accurate, you can say. So when I convert it into milli, you know how much it is gonna be? 12.9 milliamps. Even if those are getting 0.0129, if you look for the next digit, it will be around 8 also. That is gonna be exactly same value. So what I advise every one of you, whenever you convert the value, okay, so keep at least value up to 2 decimals here. Okay, no problem. If it is coming 5, it's not a big deal. It is almost close to that, 13 actually. So if it is 5, that's perfectly fine. No issue at all. Yeah, no issue at all. So this is the another way. Okay, so both way is up to you girls, which you like, or sometime depend upon the situation, what we need to do. All right, so this is about that one. Okay, now what we can do, erase all. All right, this is good. Okay, next, this is same. They are saying calculate the total. You already calculated that one. Perfect. Now there are some, what you call simplified versions of the same formula which we have just discussed. That is the general formula to get the total resistance. Now this is the simplified version, or you call special case formulas. Yani, what is a special case? They are saying in case of equal value resistance are connected in parallel. See now. So if this is a situation, we have equal value, yani all resistance are of same value. Let's suppose this is R. So all are R. So we have something like this. If you put these in place of, that will be something. Yeah. So RT is equal to R over N. What is N here? The number of resistances connected in parallel. So it's so simple to calculate the total resistance if you have multiple resistance, of same value connected in parallel. So I can easily say RT is gonna be 100 over 5 because there are 5 resistors connected. So the answer is gonna be 20 ohm. So easy. Okay, this is something. So it will make your life easy sometime, because next chapter we will be discussing, you know, combination circuits. So some resistance will be connected in series, some in parallel. But if you find some values are same which are in parallel, so I can quickly apply this law, you know, this rule, this formula. Actually, it's not new, not the law. Actually, it is the modified formula, special case formula. All right, so it will be helpful for you. Okay, good. So just move next now. Okay, this is what to find the total resistance between. Okay, it's so easy, you already calculated. Now one more, again, simplified version of the same formula. What was that? Reciprocals of the sum of reciprocal. Here is what they said. It is a special case, yani, when we have two resistances only. Yani, this time I have two resistance only, and I want to calculate the total. So rather than, you know, that formula, we even it is the same thing. See, if I just write it for you, RT is equal to, what was that formula? 1 over, or just don't say 1 over. Is it just inverse one version? Okay, what was that? RT is equal to 1 over R1 plus 1 over R2. If because they are two only, and this is inverse, by the way. All right, so if I take LCM, you know, that common you know, factor, so it is gonna be R1, it is gonna be R2, correct? So what we will be getting over there? R2 plus R1, and what is that? Inverse. So if I get the inverse, I can also say, just writing in an order, R1 plus R2 over R1, sorry, it is a multiplication, huh? So I need to make it undo. Yeah, just a minute. Where is undo? How can I do this? I don't know. Undo. I can erase it, okay. Right click. No, I'm using, you know, there's a Viacom tab. There's a Viacom tab. I don't know how to. This is there's a click. Yes, it's okay now. So pointer option, screen option. All right, taking some extra time. So I can say R1, R2 over R1 plus R2. Correct. This is something. R1 R2 over R1 plus R2, because of the flip it will reverse. Okay, so this law is also called as product over sum rule. Product over sum rule. So this is the actual formula. This will also help. So rather than writing this one, I can quickly say multiply them, add them, and divide bus. So I can quickly get the total of two resistances. This is a shortcut. But see, it is applicable for two resistances only. But for example, if you have one more resistance connected here. Let's suppose we have one more resistance which is connected here. So this is R3. So you can also find basically, you know, the same for that one. But how can we do this one? So just put here in this formula, need to update this formula. So I can just update it, just remove something. I am just erasing from here, and this one also. Okay, just erase everything. And when you just put the value, guys, I'm just writing the formula, what you will be getting directly. Okay, so it will be coming something like that after putting the value. Pen. So this is 1 plus 1 over R3. So you know what you will be getting? It is inverse definitely. So I'm just solving directly. So it is gonna be R1. So difficult. first of all I'm using from here and it is creating problem. Khalas, I will use it from here. Let's see now. So this is what I said, RT is equal to, it is gonna be R1, R2, R3 over R1, R2 plus R2, R3, plus R1, R3. It will be something like that. Understand? So after simplification, so it's up to you. If you can memorize this one also, so it's for you. Otherwise, you can use the general one, which you know already. Simple. Okay. So I just make it simplified for you. So usually we used to have 2 resistances or 3 resistances. So 2 is this simplified, and this is the for 3 one. Okay. So this is 3 resistance. Clear? Later on, it is gonna be very difficult. Yani 4 we cannot, because it is gonna be very difficult. So this is so simple. You know what simple? Just product over sum. This is product. This is R1, R2, R2, R3. What is remaining? R1 and R3. Yani each one will multiply with the another one. This is the way. So it's up to you how you memorize. I memorize this way, and it is long lasting for me. So this is something. All right. So it will also help you. Why I'm teaching you? Because later on student thinks, teacher, the time was very short. I was, I can solve everything, but the time was very short. Wallahi, I know everything. So I know you know them. But whenever exam is there, you have a limited time and you need to perform within a limited time. So if you know these formulas, you can quickly apply. So I'm teaching you this way. All right, now just clear this one, move next. What is here? So total of this one, you can easily find out, it's there. Now, what is that? Find the current voltage and power across each of the resistance. Okay, we have already calculated some of the values. So tabular form, we are just going to look here. So you can see here, we know already the resistances. I just put it over there. Vs is given already. So it's so easy to find V1, V2, V3 because it is in parallel. So they are gonna be same. So I can quickly say all are same. Okay. Now current we have already calculated. So just putting here. See, it is calculated here up to 1 decimal place. Yani 1 digit after decimal. But the one which you will be calculating with the 2 digits, that is gonna be more accurate. And I'm expecting that we will be following that rule. So, yani I can check, you can check, and your friend can check. Yani the rule will be, we'll always consider 2 digits after the decimal place. Okay. This is something. So 13 is they are getting. We already get it 12.95198, which is almost 13. All right. Now the power. So guys, for the power, the formula is same. What you learned in the previous chapter. Either P is equal to V into I, or V square over R, or I square into R, whatever. So the easiest one, if you look here, is the multiplication of voltage and current. So you know that voltage in volts and current is in milliamps. So ampere and volts will make watt, and milli it is in multiplication, so it will be with it. So what I need to do, I will just multiply the number, then these two numbers. Multiply, answer is 36.8. Same you can go for another one and you will be getting all the parts. So this way, power 1, power 2, power 3, and total power, girls, it is the same law which we learn for the power series circuit. Yani total power is basically the sum of all the power drops. So if I add P1, P2, P3, I can get it the total. Also, the total can also be calculated by the formula. What is that? Vs, okay, multiply by the 13, yani V into I. Simply, I can get it this one. So this is the way. See, Lina, what is about the conversion? It is already converted. It's up to you. I told you, it's up to you. How you will convert? What you want to convert it? Tell me.
That's what I mean when we found the power.
Okay, so par is okay na, it's okay. It's in milliwatt, it's coming. See, if it is not in milliwatt, you know what it will be? It will be 36.8 into 10 power minus 3. Will it be like that or not?
Yes.
So we know that minus 3 is what? It's a milli basically. So
Yes,
it is always, yeah, it is good. We should write our result this way with the prefixes rather than 10 power. That's why I told you, if you are just relying on calculator, so calculator will not write milliwatt. It will simply multiply and give you the result, and that result which you will be getting, if you put this 7.4 multiply by 10 power minus 3 and multiply by 5, your calculator will give you this something, or not this, it will give you this, which is gonna be 5, I believe, or how much it is gonna be 36. No, here is 3, and in this case it will be 4 minus 4, something like that. 2. This is like that, minus 2. Is it like that? 3.68 into 10 to the power minus 2. This will give you. So you have to write watt. But this way, if we go, we can also write in milliwatt. So no need to convert it. Why you convert it? It's so simple. Because milli is there. It is in multiplication. So milli, and this is ampere, this is volt. So multiplication will give you milliwatt simply. And you can just multiply in this situation 7.4 with 5. That's it. No need to go, further. Is this okay? All right. Okay. So erase all. Okay. Now. Okay, guys. So next is node and branches. Though I have already explained to you what is node and what is branch. So you can also see here. So what is node? Any point where 2 or more circuit elements are connected together. 2 and more. So you need to find the nodes. How many nodes are there? You know the rule. I have told you. So where do you find 2 and more circuit elements are connected together? What are the elements? Voltage source, resistors are, this is also resistance, this is also resistance, this is current source, this is volt source. So find how many nodes are there and also how many branches are there. First find the node. As I told you, node is what? The point where 2 and more circuit elements connected together. 8 nodes. Okay. Is this answer or question? You put question mark. Okay. Answer. Okay. What about others? Manar, 4 branches. Okay. What about others? Lina said 3. What is 3? Nodes or branches? Three branches. Okay. Nodes are 8. Okay. So would you like to tell me where are the 8? 3 branches, 4 nodes. 4 nodes. Okay. What are the 4 nodes? Can you please tell me? 4 nodes.
It's between the R1 and R2.
This one?
Yes.
Okay.
And then the next one is this one.
Okay.
And then at the bottom also of R3.
Okay.
And at the bottom of R2.
Or intersection. Jana said, yani or intersection. Or intersection. Or intersection. Or intersection. Okay. This is node. Yani 1, 2, 3, 4, 5, 6, 7, 8. What you just tell me, it's not a node, it's called joint. They are joined here. But what node says? Node says 2 or more circuit elements. Okay. Now, what are the circuit elements? This is a circuit element. So this is called one branch. This is a voltage source circuit element. It is called one more branch. This is a circuit element. It is called a branch. Yani circuit elements is equal to the branches. This is the circuit element and this is the branch. This is the circuit element, so this is a branch. So how many branches now?
5.
5. Yani number of circuit elements is equal to the number of branches. Is it clear?
Yes.
Okay. Second thing about the nodes. What node says 2 or more circuit elements? Okay. Now see. Is this same or not? Same point or not? Same. So single node. One node, yeah, it is single node. Also, from here to here, is this same or not? Same point, yani? Same. Yani second one. Third one. Here it is meeting 2 points also. So this is again a point where 2 and more circuit element, yani R1 is circuit element and VS is a circuit element. So this is the third node. So how many nodes are there? 1, 2, and 3. Just wait, Batul, I will tell. Batul. Okay, so clear now? Nodes are 3. Okay. Any question related to the nodes? Clear, huh?
Yes.
Okay. Yes. Batul, this is about the branches, yani the circuit elements. So what are the circuit elements here? We have resistance, we have voltage source, we have current source. So this is called a branch. This is called a branch itself. This is a resistance. This is called a branch. This is called a branch. Understand? This is also a branch. But see, this is not a branch if you think. This is just a wire which is joining two, branches together. This is a node, but this is a wire, but this is not a branch. Similarly, this is also a branch. This is also a branch. This is a branch, yani R1, and this is VS. So this is one branch, second branch, third branch, fourth branch, and fifth branch. This is. Okay, what is Mariam? What happened? Manar?
I didn't understand notes.
Okay, what about Manar? Notes. Okay, very difficult, huh? Notes very difficult. Just a minute. Just make it easy then, if it is difficult. All right, I am redrawing this circuit. Okay, this is R1, this is VS, this is a point. Which point? This point. Now let's make another point, which is this point. Yani this is the same point. This is that point. So this is, let's say, B. Let's say this is A and this is C. So this is C. So A, B, C. Now from the C, this is all are same. You know, this is just a wire. Can't I connect this R2 between this and this? Any problem? Can I connect it like that? No. Why I can't connect it? What is the problem?
It's parallel.
See, this is what is just, it is just a wire. It is just a wire. If I just make short wire, what is the problem? This is a long wire. You know, same circuit can be drawn in a different way. It is just, I told you in the beginning, shape doesn't matter. What matters? I told you that what matters, the concept, how they are connected. So the same circuit I can redraw. See here. So R1 Vs, and now this is R2. Now this is R3. Now this is, sorry, this is the current source. This is current source, which is IS. IS, R3 and R2, R3, and this is the current source. So this is one node where all ends of the, you know, resistance and the source is connected. This is another node and this is another node. So I can say this is A, this is B, this is C. I said this is same line, same thing. This is same thing, and this is also like A. So where is the problem?
Yeah, now it's clear.
It's clear. Okay. What about Lena?
But it's hard from the original graph.
No, that's why, that's why it is drawn like that, so that it looks simple, simplified version. But it is something like that. And I told you, this is just a line, just a wire. You know that you are using your laptop, okay, but see, the laptop is consuming the power, but you may have short wire or you may have length, you know, long wire. So you need to connect to the plug in the room. So you connect, maybe you can have very close, you can connect it, someone can have a far away, so they need to have an extension. But extension is not going to utilize the power. What is going to utilize? The load itself. So wire can be length and short, it doesn't matter. But who is consuming the energy? The laptop. Here who is utilizing the energy? The resistances. So resistances are main thing. Okay, how they are connected? I told you, this point is same. Similarly, this is same. Understand? So because of this, they are joined with a wire. So I can say in total, this is a point A, where R1 one end, R2 another end, R3 end, and this one end is connected. This is something like that. Is it clear now?
Yes.
Okay. Yeah. Similarly here, we can say this is a point where this one, this one, this one, this one is connected. But just to make it easy, you know, look at, you know, good shape, we just draw like that. This is something. The concept is there, and the concept says simply this is a single node. Okay. This is a single node, and this is the third node actually, which is shown here. Okay, by the way, for your information, if I change a little bit, where if I put now, Now tell me how many nodes are there if I put a resistance there. Total nodes. I just connect this one here. 4 nodes. Okay. So one node, another one, and this is itself a node. Okay. And this is gonna be another node because it is connecting this branch and this branch. And this one is connecting this branch and this branch. This one is connecting this branch and this branch. This one connecting all ends here. So we have 4 nodes. Is it clear now? Okay, this is about the nodes and the branches. Branches is number of elements itself. So see, it's there 3 nodes. It is a single node. It is a single node and it is a single node. So 3 nodes are there. Branches, the circuit elements between 2 nodes are called the branches. What is that again? Circuit elements between the 2 nodes are called branches. So we already have this node, right? And we have this node all together. So circuit element, it is connected between 2 nodes, branch. We have another one. What is that? Is the node a wire then? Node cannot be a wire. Which node you are talking about, Jana? So this is already, as I told you, this is a single node. So between this node and this node, these 3 elements are connected. Node, branch, branch, and branch. So these are the branches. I didn't get your question, Jana. Which wire they circled? Can you show me? Which wire? Previous slide. Where is that wire? Where is that? Just showing this is all together a single node. The below is showing this is a single node. This cycle is showing this is a single node. Just to highlight, it's just highlighting you. Is it clear? Just to highlight you, this is a node. This is a node, okay? All right, focus everyone. Next is this one, Kirchhoff's current laws. So what is a Kirchhoff current law? I already explained to you. See the definition of KCL. This is the definition. The sum of the currents entering a node is equal to the sum of the currents leaving the node. Okay, so this is a node. Here we can just, as per this formula, we can find what are the incoming currents and what are the outgoing currents. So if you look, arrow showing in incoming, remaining I3 and I5 are outgoing. So I can write the formula, yes, I1 plus I2 plus I4 is equal to I3 plus I5. This is the formula, okay, of the KCL, Kirchhoff current law. So this way we can got it. Or we can say algebraic sum of all the currents is equal to 0. Yani consider that incoming currents are positive and outgoing currents are negative. So when you add them, you will be getting 0. You know that KVL can be asked, explained 2 ways. Either total voltage supply is equal to the total drop, or I can say the algebraic sum of all the sources and the drops in a closed loop is equal to 0. So same thing. Clear? KCL, Kirchhoff current law. Okay. No, Mariam, there is no relationship. They are independent. Okay, so now, so in this picture you see they are asking find the incoming current I, unknown current. So what we need to do here, we can apply KCL. Where we can apply the KCL? We can apply to any node. This is a node. We can apply KCL to any node. This is something. So here is a, we can apply KCL. So look here, what are the incoming currents? I will write here. Incoming currents. Let's suppose it is I3, it is I1, and this one is going out, I2. So just 3 is out. Or if just 3 is out, all are incoming. So it means I1 plus I plus I3 is equal to I2. So I2 is just the one which is going outside. So I can simply say I1 value is given already, which is 0.5 plus I plus I3, which is 1.9 is equal to 3 milliamps. So I can find the value of I, which is I is equal to 3 minus 2.4, which is gonna be 0.6 milliamps. Clear? So this way you can find the unknown current and you can apply KCL to any node where more than two branches or two branches or more are meeting, which is something. This is called node, and we can apply KCL to a node. By the way, this law is applicable for the parallel circuits only, because in parallel circuit we have nodes. This is something. All right. Kirchhoff current law. So as per this law, girls, we can also show that I1, I2, I3, if I get the sum, you will be getting the total current. It is because of Kirchhoff's current law. This is something. Now, girls, second thing comes current divider rule. Like we know that in parallel circuit, current divides. Okay, in series circuit, voltage divides. So we have voltage divider rule for there, but here we have current divider rule. Okay, one more thing, I assume always the current direction, yani if this is a battery, I assume that the current is coming like that. When it reach here, it will split. So I assume this direction, because in my book which I studied, it is like that. But here in this book, they are saying different. Okay, no problem. Both are same thing. See, because if you look, this is incoming, it's coming towards the node, which is that node, and others are going outward. So always the total current will be, if coming, they will be going out. If you consider that total current is going away, so others will be coming towards the node, towards the node. So this is actually the change. So it's up to you. You need this assumption or this assumption. It's up to you. So now they are saying this total current IT is splitting into I1, I2, I3, and IN. So how can we find the currents in a particular branch? Formula is IX. Yani current in branch X is equal to RT over Rx, yani the resistance in which the current is flowing, okay, multiply by IT, and you know that how to get RT. This is the total resistance of a parallel circuit. Okay, so reciprocals of the sum of the reciprocals. Okay, so this is the current divider formula, which is gonna help you a lot, because questions will come and you can easily find that one by just calculating the total resistance, and in which you want to calculate, you can apply this formula. So it's important formula, you need to memorize it. And by the way, this is a general formula. So we will be discussing now some specific or formulas, all okay, yani some short formulas. Okay, see this one. So determine the current through each resistor in a given circuit. Okay, girls, find this one. So you can see, is this parallel or series circuit? Parallel circuit. So we can apply current divider rule and see how they are showing. So this current is coming here and generating from the source. So the current which is flowing in the source branch, it is the total current. Keep in mind, because this is a source. And now it is splitting into this current, and this current. They are asking determine the current through each resistor. So how can we find? We have not given the source voltage source value. We know only total. Okay. All right. So Phi calculated the total resistance. All right. So you calculated RT is equal to 110.54 ohm. Okay. Yeah, current divider we need to apply, but in order to apply the current divider, we have to calculate the current total resistance first. So this is the total resistance. All right. Then after that, you can apply current divider and calculate how much. Now calculate the value. Don't tell me the formula. I know all the formulas. You have calculator, I don't. So calculate the final currents I1, I2, I3 and then tell me. Okay. So I1 is, how much is I1? 1.62. 3.34 milliamps. Okay. Then I2 is equal to, and I3 is equal to, tell all. One by
I1 is equal 1.62. This is for
1.6.
yeah.
Okay.
And then I2 is equal 3.34.
Okay. Yeah, this is, you are saying this one is this one. All right. And this is different. How much? Okay. I1 is how much? This one. 1.63 milliamp.
And then
Okay.
5.02.
5.02 milliamps. Okay. This is I3. All right. So I3, all right, yes, okay, correct. So this is something, okay, if you just add them, you know how much you will be getting?
10 milliampere.
10 milliampere, because of KCL, Kirchhoff current law. So you know these things. Also, you can see one more important point, which current resistance is the largest one here? Which one is the largest one?
I3.
I3, R3 or R1? Resistance. Which is larger one? R1. So see, the largest resistance is having
The
least current because of it opposes the flow of current. It says no, I will not allow to flow. So it will resist more. This is the point here. All right, good. So you got the point. Now is there any other way to calculate the currents? Yes. Okay. If I ask you how much is the voltage source value, What is your answer for that? Find the voltage source. Value of voltage source. What is this one, Jana? Okay, 1.1 volts. Okay, you said 1.1 volts. May I know how did you calculate it? .1. See,
I total multiplied by R total.
okay, so how much it will be? See, every one of you, see, most of you, or your units are always wrong. Like Shahad, right? 11,5.4 volts, mashallah. Another one said Lina 10's power 10's power minus 3. Okay, then, and if you don't write formula, calculate it. Another one said 1105 millivolt. Okay, but see what is the final answer? Okay, so what is the final answer? 1105. Okay, 11 volts. Let's see now, new result. Rina said 11.04 volt. Okay, so this is only one result, which is 11.04, which you typed here. Otherwise, all are different. Now Shah said another one. So did you get the problem, the common problem, what I am observing? You people are confused still while you are multiplying the units, and you are still not able to find the exact unit, So this is actually, you are going to lose the marks because of it. Though it should be very simple. Since beginning, I am insisting and telling you this should be like that, this should be like that, but you people still have confusion. See, just forget to say we need to convert that, convert. You have to do what you want to do, because I have already taught you how to convert. Khalas. See, so only Rinad give the answer 11.04, other than no one. Okay. So now look here. I will not teach again and again these things. I'm just telling last time. This is VS. It should be IT, or right like this, multiply by RT. Okay. Now IT. So what is IT? If you look for the IT is given to you 10 milliamps. I can write this way. Okay. Problem, you people rely on the calculator actually. For me, I don't like calculator. I can calculate all the calculation myself. I don't need it, So 10 milliamps, then RT. So RT you have calculated, and you said it is 110.54, and it is in ohms. Okay, ohm. So we know something. What is that? Ohm multiplied by amps will give me the unit, which is called volts. Do you know this one? Amps, ampere multiplied by ohms will give me a unit which is volts. Clear?
Yes.
Okay. If I want to keep it with me, this one. So what I need to do, milli is in multiplication, so milli will also come. Yani it is in millivolts. Because of this is in product, milliamps multiplied by ohms. It is millivolts. Now, what is remaining? Now I will take my calculator. I will multiply 10 by this one. Okay. And it will, when I multiply, I will be writing, because of 10, 0.54. You know, when I multiply by 10, it should be the result. You can check yourself if it is wrong. I am not using calculator. This is the result. Now, this is in milli. If I want to write it into volts, it is so simple because it's a milli and milli is the lower unit. If I want to go for volts, so I need to, what I need to do? I need to divide by 1000. So if I divide by 1000, you know what? 11 volts. Why? Because when I divide by 1000, so sorry, not 11 volts. When I divide by 1000, it is gonna be this one 0054, something like that. Is it correct? When I divide this one by 1000. So here, what we got, yani see this one. I told you, girls, just write your answer up to 2 decimal. So this is 2 decimal. Yani I have to drop this 0. So no problem. This is something which I should report. My result should be like this. And I will say, this is my result. Yes, Jana. Yeah, you are right. Those are getting 1.1. They are all correct now. Yes. 11.5.4. It is absolutely wrong. You can check it. When I multiply, yes. So it is yes. It should be 11.54. So Sarah, you said 11.05.4 milliamps is the correct? Are you saying like this?
No, the answer that you have written here in the slide is not correct.
Where is the answer?
You wrote 1100.54, and the
Yes.
answer would be 1105.4.
Oh, just a minute. Correct. Yani this point will shift here. Yes, absolutely right. You are right. This should be like this. Yes, this is correct. Yeah. So this is something. All right. So this is, and now when we convert it, so it is gonna be 0.5, you know that one, and 4 after dividing, you know, 1000. So we need to drop this 5, and you know that round to even rule. So this is 5. So definitely I will not make it 1. So that if I put this one, it will make it odd. So I will just keep it 0 and drop this one. So my answer is gonna be again same. Yeah, this is the answer. Correct. Is this okay now?
Yes.
Okay. So this is the way. And see, this is so simple. You need to do practice about this one, milliamps or amps. So it's up to you. If you want to convert, if you want to write, see what you actually you are using just calculator. So rather than writing this one, you know what you are doing. You just put okay 10 multiply by something like that. What is that? Multiply by 10s power.
Minus.
What is that? You know, minus 3. I know this is because you just think that even nothing. You want that the calculator will give you everything. So calculator will give you the multiplication or division unit. You will choose. So if you go this way, for example, okay, and you just multiply this way, for example. So you know what the calculator is going to give you. Is it? This is not calculator will not give you this one. What it will give you?
1.1054.
Yes, it will be something like that. 5, then multiply by 10's power, how much? Minus 3. Is it correct? Is this what you are getting from the calculator? You can check if you want. No. Then what is here?
No,
Tell.
without.
Bus simple this one. This is exact this one, huh?
Yes.
Okay. Yes. So in this case, you will be getting some. Okay. Sorry. Now I cannot do anything. So yeah, this is the unit which you are getting, because here is you put like that, but some cases you will be not getting exactly same answers. So at that point, you know, because of if there is a large multiplication, so you will be getting something in tens power. So it's up to you, yani, how you are converting sometime. It is okay here because it's just multiplication, you are getting 1.1055. So you will report quickly, okay, this is 1.10 volts is the answer. So it's just practice and you will understand, inshallah. Okay, so next is the current divider rule for two resistances, girls. Two resistances, special case, right? This is a special case. So it is like that. What is that special here? Yani, they are saying this time we are not having multiple resistance, we have two resistance only. Two resistance. This is the total current, and current is divided into two parts. So you know that already the general formula. What is that? Ix is equal to RT over Rx multiplied by IT. All right. So this is a general formula. It is also applicable. You can also use the same formula if there are two resistance, three resistance, four resistance, whatever. But the one which is down, it is the shortcut or simplified version for two resistance in series. So in parallel. What is that? It is this is actually work this way. And if I want to calculate I1, I need to consider what? Not this same resistance. I will look for the another resistance, yani R2 over their sum, R1 plus R2 multiply by the total. Bas, this is a formula. And how did it come? It comes from the same, you know. If you put here I1, so your formula will become R1 multiply by IT. And you know how you will be getting RT? Because two resistors are in parallel. Do you remember that product over sum? Product over sum. So I will be writing R1 R2 over R1 plus R2. Am I right, girls? Product over sum when two resistors are in parallel, right? So this R1 will cancel this R1, and when you rewrite it, it is gonna be written like that: R2 over R1 plus R2 multiply by, which is the same which is here. This is the same. It is derived from the general formula itself, but it looks simple. Okay, so the only thing is how you can memorize it. It is like if this is resistance 1, so in the numerator you will be having, sorry, if this is current 1, so in the numerator you will be having resistance 2. If you are writing for let's suppose for I2, so my formula will be, what will be my formula? I2 is equal to R1. This time it is gonna be R1 over R1 plus R2 multiply by IT. This is gonna be the formula. Okay, so this is called current divider formula. Do you remember voltage divider formula? Voltage divider formula, when two resistors are in series and we can apply voltage divider. Okay, what is that? If I want to calculate V1, V1 is equal to R1 over R1 plus R2 multiply by Vs. You know, this is voltage divider formula. So it is in the same format, but there is some change. Can you just compare V1 and I1 formulas and just try to find what is the change, because you already remember this. So how can you remember this one? Just for that, try to find the relation changes, then let me know. Tell me what is that.
And I1, the numerator R2, I is 1. But
Okay.
V1, the numerator is 1 when V is 1. So 1,
Yes.
1, V1.
Correct. So this is the change bus. So if you know this one, so current is gonna be exactly same, except that this is I1. Here we will be using R2. But if this is V1, so we will be using R1. Same. This is something. Definitely, this is voltage divider. So I am going to have V here and V total. Here, this is current divider. So current here, total current here. That's it. Okay, clear to all?
Yes.
All right. So this way we can easily memorize the formula. Okay, so it is helpful. Later on, I'll show you how it is helpful. All right, just move next. Okay, see this question. So sometimes question comes like that. You are not going to have all the time circuit. Sometimes it will be coming like that. So read it and solve it. First check what is given and then solve it. All right, so I1 is 5.449. Okay, so you can write in, as I said, up to 2 digit after the decimal. So I can say 5.45 milliamps. All right. Okay, then I2 is how much it is coming? Yeah. Okay, how did you calculate I2? Which formula you use or which law you use to calculate it?
The current
It is
divider.
It is R1 over R1 plus R2 multiplied by I total.
Yeah, you use the current divider formula.
Yes.
All right. Is there any other way other than using current divider? Can I use any other method? Do you think? Which one? Kirchhoff? Kirchhoff's current law, KCL. Yes. Yeah, it is, easy in this case. Why it is easy? Because we know that Kirchhoff current law says this is I1 plus I2. So here I can simply calculate I2 is equal to IT minus I1. Is it correct, girls? Which is simply, I can say 8 minus 5.45, which is 2.55 milliamps. All right. This could also be used. So maybe it is just a what you call just subtraction type. So it is basically helping more rather than just applying multiplication, addition, and all. So it's up to you. So that's why I keep on asking, Yani, you should not restrict yourself. You can go this way, that way. From all the ways, you will be getting same answers. More easy, yeah. It is definitely more easy. So, but why it is easy? It is easy because you know the rules, you know the formulas. If you forget, you cannot do it. You need to spend more time, but no problem. You will spend more time, but you will be getting right answer. But in the examination, the time matters. Time also matters. This is something. All right. Let's move next. Okay. What is here next? Okay, just calculated this way. Now, see this question and solve it. Question clear? Any doubt? Are you working on it, girls? Silence.
Yes.
Okay. Any confusion? Thinking. Okay. Okay, what is that? Yes, but I have a question. Does the fuse affect the voltage? No, Shahad, fuse is just a wire, you know. What is a fuse? Fuse is just a wire. So what a wire will do, it will do the same. Just a connection. Yes, no. Okay, what about the R3 and R4? Any confusion regarding R3 and R4? Or it is clear to all of you? I hope it should be clear to all of you. Yeah, yani R3 and R4, they are in parallel also, because there may be a confusion, but I explain you very well there. So I think it is clear. Yeah, so it is gonna be 25 everywhere. Absolutely right. So you know the reason is yani I can also connect R4 rather than if I remove this wire and extend this wire up to here. The same thing, because it's just this length is just a wire. So this point they join here or they join here, same problem, same point. That's why. So it is a parallel, complete parallel, purely parallel circuit, and this is the voltage which is appear here. So everywhere voltage is gonna be same. Yes, this is right. All right, this is easy and you got at this point. All right, see the next, this question. 25. Okay, that is okay. Now see this question. What is this V here in the picture? Confusion? Battery. Okay. Who is teaching you the lab?
Miss Mahwash.
Okay. So did she explain to you voltmeter, ammeter, current meter, something? Okay. So is there any, how many experiment you have completed? One experiment,
Just
two
one.
experiment?
Only
Just
one.
one. Only one.
Yeah.
Okay. So it is, it is the symbol of basically voltmeter. And what is a voltmeter? Voltmeter is something which measures current. Okay. Yeah, this is voltmeter. It's not a source. It is meter, measuring device, which can measure the voltage. Okay. This is the battery. This is the source. Just okay. So now they are asking simply determine the voltage across the resistor in given circuit. So how much is the voltage? So voltmeter, what is it will read here? They are asking like that. If the Vs is 5 volts. So it's simple now. Check it now. Tell me. Is it see this one? Yeah, it is gonna be 5 volts everywhere, right? Because it's a parallel circuit. All branches are in parallel. This is not a source. Keep in mind. Okay. Now again, go for second question quickly. 50 volts. Yes, absolutely right, Shahad. It is gonna be 50 volt everywhere because they are saying the voltage difference between these points are given 50. So this is in parallel. So this voltmeter V1 will read 50. This voltmeter will also read 50 because they are in parallel. Correct, but this is the logic here, not more. All right, good. So it's just understanding of parallel circuits. Now see this one. It is interesting something. Determine the current in each resistor. So let's see how you will be solving this. So this is today's, what is the time now? 4.46. So we can, yeah, have this could be the last question then. All right. So how you are working solving this, girls? Okay, 10 I1 10 milliampere. I1 10 milliampere. I2 4.55 milliampere. Clear side 1.34 milliampere. Okay. First, you should calculate, I believe, total resistance. Correct or not?
Yes.
So first, no one just tell me about the total resistance.
Total resistance.
Yeah. Total resistance is very important. Then only you can find something.
Is it 3.36?
I don't know how you people are calculating this one. How much you tell? I will write it here. How much you are getting? RT.
That is
Okay.
0.51.
0.51. Okay, so this is in actually all are in kilo. So you calculate maybe in kilo. Okay, how much? 0.552.
52.
Okay, so
The 2 is
now,
3.
okay, so 0.52. Then what is the unit? Zahra is having mega ohm or milli ohm. It is not clear. Kilo ohms. Okay, kilo. This is RD. All right. This is RD. Then I1. How much is I1, girls? Then you can apply just formula, right? You can simply apply the formula. It's okay. Then I1, whatever you are getting, it's accordingly. The formula will be what? Current divider. And what is that? RT over R1. It is like the RT multiplied by I total current IT divide by simply R1. Is it okay? This way you can solve this one. All right, girls, clear to everyone? Yeah, let's see. Then I1 you are calculating. How you are calculating, you can check it. Okay, other than this approach, then you are applying here current divider rule. Is there any approach, do you think?
Finding the voltage.
Yes, Mariam, this is also possible. We can find the voltage which is Vs, source voltage, which will be IT multiplied by RT. Yes, after getting this one, and we can say that what we can say V1 which is equal to V2 which is equal to V3 which is equal to V4 is equal to Vs. Then we can apply here, just Ohm's law. So it will be simply I1 is equal to V1 over R1. Clear, girls? This one, this way. So this could be more easy, I believe, because here you need to apply current divider formula again and again. So all are okay. Whether you go this way or that way, you will be getting the exact same values. Clear? Finish now, boss. This one, okay?
Yes.
All right. So you can cross check easily, and in order to cross check, you know already the total current. So total current will be the sum of all the current, which KCL says. You can cross check your answers as well. Yeah, it should be 10. Correct. Okay, now see, calculate the RT. So you know, two resistors are connected in, and this is the terminal. Between that you have to calculate. So they are connected parallelly. Do you remember the formula? Product over sum rule. Correct? Yeah. I tried another way which was total, but I don't know if it was correct. What is that? Yeah, it is correct. Fatima, it should be correct. Definitely, it should be correct. You can just add all the resistance, all the currents, and you should get 10 milliamps. That is okay. Okay. Okay, that's good. Similarly here, see this one. It is a common node where R1 and R2 is connected. Shape doesn't matter. You know, this circuit could also be drawn this way. Same. We can also draw this way, you know. This is a parallel. Any R1 and R2 both are sharing common nodes. They are connected end to end. So this is one end of both the resistance. Another is also another resistance. So you can also calculate that one. Is it clear, girls, to everyone? Okay. That's it. So this is clear. Yes, fine. So bus here in this is the par formula, which is almost same everywhere. So you can, yeah, series or parallel, same formula. So we can stop just now, and inshallah we'll continue tomorrow. Okay, you have tomorrow lecture, I believe. So we can continue tomorrow. Okay. All right.